In this video, we're going to have a look at forming differential equations that involve flow rates and changing concentrations. This is a pretty common sort of exam question, and they look like this, where we're given a lot of information about a container with a liquid, in this case, flowing into the container. It's also going out of the container, and we need to form a differential equation. So we'll come back to this question at the end. You're always going to approach these questions in the same way. You're first going to find the volume of the water in the container after t, whether it's minutes, hours, days. That's then going to give you the concentration of the chemical or the salt or the pollutant or whatever it is we're talking about in the container after t minutes. You're then going to be able to form your differential equation using the general formula that I've put down there at the bottom. So I'm going to talk through each of these steps, and then we're going to look at how to apply it to this exam question. So, first of all, really simply, the volume after t minutes. So, in this case here, I have got a container that's got an initial volume of some liquid inside it of 100 litres. We have got a liquid flowing into this container at 7 litres per minute. And we, at the same time, have got liquid leaking out of the container at 10 litres per minute. I want to know what's the volume of the liquid in the container after t minutes. So I know after 1 minute, 7 litres has gone in. I know after 2 minutes, 14 litres has gone in. After 3 minutes, 21, and so on. So generally, after t minutes, 7t litres have gone into that container. At the same time, we've got 10 litres per minute leaking out. So after 1 minute, 10 litres have leaked out. After 2 minutes, 20 litres have leaked out. After 3 minutes, 30, and so on. So generally, after t minutes, 10 t litres have leaked out. So we started with 100 litres inside this container. 7t has gone in and 10t has gone out after t minutes. So our volume after t minutes is 100 plus the 7t that's gone in minus the 10t that has gone out. So it would be 100 minus 3t. So that will tell me the volume of water inside this container after t minutes. That's your first step in solving these problems. Next step. We now want to get an expression for the concentration of the chemical or the salt, or like I say, whatever it is that's inside this liquid or gas. So we saw a minute ago that the volume of the liquid inside this tank is 100 minus 3t. If I said that there were x grams of chemical inside this tank, then the concentration of that chemical would be how much of the chemical we have divided by the volume. So the concentration of the chemical in this tank after t minutes is the amount we have divided by the volume, so x divided by 100 plus 3t. Now, here's where a key assumption comes in. This x minus 100, x divided by 100 minus 3t, that's the general concentration within this tank. Now, we are going to assume that the tank keeps on being mixed. The chemical, whatever it is being spread evenly throughout this tank. So what that means is that the concentration of the chemical here is exactly the same as the concentration here when it leaks out, which is important because that's going to allow us to say that the concentration of the chemical as it leaves the tank is also X out of X over 100 minus 3T. If it wasn't for the liquid constantly being mixed, it might be that you'd have a lot more of the chemical in the top left, for example. If that's where the chemical is being added, you'd have a lot more in the top left than you would in the bottom right. But we're going to assume that it is all the same. It's evenly spread. So we have now got an expression for the concentration of the chemical that's in the liquid that's leaking out of the tank. Okay, step 3. Let me explain this formula I had. If I say that a liquid is flowing into a container at 7 litres per minute, and that liquid contains 2 grams of chemical per litre. So there's 2 grams of the chemical in every litre. And the liquid's flowing in with 7 litres per minute. So if I've got 7 litres with 2 grams in each of them, that means there'd be 14 grams of the chemical flowing into the container every minute. We're just going to multiply these two things together, which in terms of connecting rates of change should hopefully make sense, because our flow rate here is dV by dt, the volume litres per minute time. Our concentration, the grams per litre, so grams in this case is represented by the variable x, the amount of the chemical we have, per litre, so dV, and you can see by multiplying these two things together, we do get the rate of change of the chemical. So that is why we are doing the concentration multiplied by the flow rate. We do that for the liquid going in. We're also going to do it for the liquid that is leaking out. So if liquid flows out of a container at 10 litres per minute and it contains X over 100 minus 3T grams of chemical per litre, then the chemical will flow out at 10 times the X over 100 minus 3T grams per minute. Again, just multiplying the concentration by the flow rate. So we're now going to follow those 3 steps for this exam question. We're told that a pond initially contains 1,000 litres of unpolluted water. So that's the initial volume. The pond is leaking at a constant rate of 20 litres per day. It is suspected that contaminated water flows into the pond at a constant rate of 25 litres per day, and that the contaminated water contains 2 grams of pollutant in every litre of water. It is assumed that the pollutant instantly dissolves throughout the pond upon entry. Given that there are X grams of pollutant in the pond after T days, we need to show that this situation can be modelled by this differential equation. Right, so let's follow those same steps that I just explained. We're going to first of all work out the volume of the water in the pond after t days. Okay, so we've got the 1,000 litres that we had to begin with, and we've got 25 litres per day being added into the pond. So that will be plus 25t. Then we've got the pond leaking out at 20 litres per day. So that's going to be minus 20t. So the volume of the water in the pond after t days is 1,000 plus 5t. Step 1 done. Step 2, we're going to work out the concentration of the pollutant, in this case, in the pond after t days. After t days. Right, so that's going to be, well, how much pollutant do we have in the pond after t days? Well, that's just, we have x grams of pollutant in the pond after t days, so x divided by the volume after t days, which we worked out before, was 1,000 plus 5t. Now we're going to set up our differential equation. So the rate of change of the pollutant is equal to the concentration of the pollutant flowing in, which was 2 grams per in every litre. That's going in. Multiplied by the flow rate going into the pond, which was 25. Minus the concentration of the pollutant going out, assuming, this is where we're using the assumption, so the fact that it's assumed that the pollutant instantly dissolves through the pond upon entry allows us to take the general concentration of the pollutant and use it as the concentration of the liquid flowing out. And we're going to multiply that by the flow rate of the liquid flowing out, which was 20. The 2 times 25 is 50. Then we've got the 20x over the 1,000 plus 5t, and all we're going to do now is divide the top and the bottom here by 5. So the 20 divided by 5 is just 4. The 1,000 divided by 5 is 200. And the 5 divided by the 5 is obviously just the 1t there. And there we go. You can see that we have shown, I've got my dx over dt is equal to 50 minus 4x over 200 plus t. So that was part A of that question. We've shown the formula. That's the thing that I find that students tend to struggle with these sorts of questions, because it is a complicated process. Quite difficult to do that. But if you follow these 3 steps, find the volume of the liquid or gas or whatever it is after t minutes, hours or days. Then find the concentration of the chemical or whatever it is inside that liquid or gas after t minutes. So just do the quantity you're looking at divided by the volume. And then just multiply the concentration by the flow rate. And then in, take away, out.